So we'll talk about integration by parts, which is a method for integrating that you're going to use on Core 3, and then you can use it on C4 as well. I'll show you the method, or the form. It's basically a formula you can use. I won't go through why the formula works. You can, if you want to know any more about it, you can look that up. So it's basically a formula that you can substitute stuff into, and hopefully what it gives you is something that's easier to integrate. Okay, so it doesn't do the integration for you. It tells you this integration that you're trying to do that's hard is equivalent to another integration that's a little bit easier. Okay, well that's how it should work. Okay, do you know what it's for integrating? Do you know what sort of things it is used for integrating? Multiply together, so it's a product of two things. So we use it, so it's used to, integrate the product of two functions. And what I'll do is we'll write down the formula here, and like I say, I won't go through the proof of it, but we'll just write it down and see if we can use it. So it looks something like this. It says if you want to integrate u dv dx like that with respect to dx, so I'm trying to integrate that, then it's the same as u times v minus the integration of v du dx. Okay, just put a box around that. So that's basically integration by parts written down as a formula. Okay, again, it's in the formula book, but you probably should use it so often that you just remember it. Is that right? Can you remember that? Yeah, okay. So what we'll do is we'll do an example. We'll do a few examples, and then we'll see if we can do it. But first of all, we'll start with some indefinite integration. Do you know what I mean by that? Doesn't have the limits on, yeah. So we'll do it without the limits. So we need to put a constant in, and then we'll do it without, and we'll see how we do both. Okay. So let's do an example. You see this all right? It's quite bright in here, isn't it? Let's say I want to integrate. We'll just do that question there. I want to integrate x multiplied by e to the 2x dx. That's what I'm trying to integrate. Okay. So what I want to do here is what are the two things that I've multiplied together? Yeah, so I've got the product of two things. I've got the x and I've got this e to the 2x here. Okay? And I've got to decide one of them is going to be the u, and one of them is going to be something that has already been differentiated, dv dx. Okay? So one of the things is going to be a u, and one of the things is going to be, so one of the things is going to be a u, and one of the things is going to be something that we've already differentiated. Okay? Does that sort of make sense? Okay? Now, just because it's written x times e to the 2x doesn't mean that the x is necessarily going to be the best thing to be a u. Okay? So have a look at it. Which one am I going to pick to be the u, and which one am I going to pick to be the dv dx? And why? Any ideas? Yeah, if I pick the x to be a u, yeah, then I look over through this integration by parts formula, and I've got a u here. Well, that's fine. That's just going to be an x. But over here, I get du dx. Now, du dx is just 1. Okay? So this thing over here is hopefully going to be something that's easier to integrate, because half of it, it's basically v multiplied by 1. Okay? Rather than multiplied by x over here, you see. So I basically look at which one I'm going to pick to be u and dv dx by looking at the integration by parts and seeing what's going to make it easier. Okay. Now usually if you've got an x, you want that to be a u because in the equation you've got a du dx, so it just goes to 1. If you can make things go to 1, that's nice. Okay, but just don't always just write the first thing down as the u, because it might not always be like that. Okay, so that's going to be the u, and so this one must be the dv by dx. Okay, and what I'm going to do is I'm going to write down all the things I need for the equation. I need a u, a v, sorry, I need a u, a v, and a du dx. So we're saying that u equals x, and so du dx must be equal to 1. Okay, and I'm also going to write down, we pick dv dx to be e to the 2x, and I'm going to need v in the equation there. So can you tell me what v is? Can you integrate that, e to the 2x? So this is like integration by inspection, this thing. It's definitely got an e to the 2x. That bit doesn't change, and there's a half in front. So those are that's the u, the dv dx, the du dx, and the v. And now I just have to put it into the equation. Okay. So this is what we should get. The integration of x e to the 2x dx is equal to u times v. So it's going to be 1/2 x e to the 2x. Do you agree with that? Take away the integration of, let's look back at the equation, v du dx. Okay, so v is 1/2 e to the 2x, and du dx was just 1, wasn't it? So I'll just get to there. Okay. So this thing on the right, you can see, is easier to differentiate than the thing that was on the left, you see. And then I just add this little bit on. So let's write it out one more time and just tidy it up. So this thing that I was asked to differentiate should be the same as 1/2 x e to the 2x. I can take the coefficient out the front, so it's minus 1/2 of e to the 2x. So all I've got to integrate is this e to the 2x. Okay? So do you want to have a go at that? What's the e to the 2x? Can you integrate that? This is all the same. What's this bit? What's the integration of e to the 2x? Or do I get v integrate it? We've actually already done it once, I think. E to the 2x, yeah. Yeah, so I've got this minus 1/2, because that's in front, and the integration of e to the 2x is 1/2 e to the 2x. Okay? Plus c, right? Okay. Okay, and all I have to do now is just tidy this up a little bit. So I've got 1/2 x e to the 2x minus 1/4 e to the 2x plus c. And can I factorise it? You've essentially done the problem, but can I tidy it up at all? What can I take out? Yeah, and 1/2 I can take out as well. So I can take 1/2 e to the 2x out, and then so what do I get in the bracket? X frill plus c. That's it. That one's done. Okay. Any questions? Shall I give you another one today? Okay. Okay, that one looks quite nice. So I'll give you another one to do. I'll give you a few minutes to do it, and then we'll go through it. So have a go at this one. Okay, see if you can do that. So we've got theta, sine theta, d theta. First of all, we've got to choose the u and the dv, d theta. Yeah. So what did you pick to be u? Yeah. Why did you pick u to be theta? So it's going to go to 1. Yeah. And dv d theta is then going to be the sine theta. What's du d theta? You just said it was 1. And what's v then? negative cos, yeah. Okay, excellent. So now I just sub those in. Okay, so I sub them in, and what I get is that theta sine theta d theta should be equal to u times v, so that's minus theta cos theta, take away the integration of v du dx, so that's just minus cos theta. Now if it's minus cos theta, I can take the minus out front and that becomes a plus there. Is that okay? Right. So now I just need to sort out this bit on the right. That stays the same. Integration of cos theta, sine theta. And there's a plus c as well. Okay, that's it. Done. Okay. So should we do one now, a definite one with some limits on it? Okay. Okay. So this example is going to be definite integration. Okay. And I want to integrate. What should we do? Yeah, we do that one. We're going to integrate between 1 and 0. Now when you do these and you practice them, you want to practice them with ease in. You want to practice them when you integrate in trig functions, so the limits could be pi and do you see what I mean? There could be angles. Okay. So try that one then. Integration by parts with some limits on. Okay. So let's just go through this. What did you pick? What did you pick to be the u? Yeah. Any reason? Because it goes down to 2, it's going to make it easier. So dv dx. Sorry, dv dx. Just do that. So dv dx is e to the x, yeah. Du dx 2, and v. It's just e to the x, yeah. You happy with that? Okay. So now I just write down the equation. Now, there's one thing different you have to do here. Okay, let me just point it out. It's to do with how you write it down. Okay, this is going to be equal to u times v, so it's 2x plus 1 times e to the x. Okay, now when we do the integration of this, we would put in 1 and then take away 0, right, because of the limits. So this bit is like, this bit here is something that's like already been integrated, you see? And I've got to sub my 1 and 0 into it still. So I'll put this bit in a box. I didn't do this on the other one because I didn't have to worry about the limits. I'm going to put this in a box. I can put 1 and 0 on there. That's a 0. And I'm going to remember to sub in 1 and take away when I sub in 0. Okay, so that's the only difference there. Okay, and then I'm still integrating between 1 and 0. And this is v du dx. So this is just 2e to the x, but I can take the 2 out because it's just a number and do that. Okay? So I've still got this 2x minus 1. Oh, it's plus 1. Yeah. 1, 0. And then I'm going to integrate e to the x. When I integrate e to the x, I get minus 2 e to the x. And again, I've got to sub in 1 and 0 into there. Okay? Happy? Is that what you got? So let's just sub it in now, because this is the hardest bit. So subbing 1 into this, what do I get when I sub in 1? I get 2, is that 3e to the x? Sorry, 3e to the 1, so that's 3e. Okay. When I sub in 0, I get, what do I get when I sub in 0? 2 times 0, yeah, plus 1, so that's just 1. E to the 0, what's e to the 0? 1. So you've got to be careful there. It just doesn't, usually when you sub in 0, things go, right? It doesn't go here because it's e to the 0. So this is just take away 1. Do you agree with that? Okay. And then I'm going to minus, and again I'm going to sub in 1, and then I'm going to take away when I sub in 0. So if I sub in 1, I get e, and if I sub in 0, I get 1. Okay. And now I'm going to tidy all this up. So just be careful when you sub in these values into these things, because when you've got e's and luns and things, you have to be a little bit more careful. So what am I going to get? I'm going to get 3e, and then I'm going to take away 2e, so I think that's just an e, minus 1, and it's going to be plus 2, isn't it? So is that just plus 1? Is that what you got? Excellent. Okay, that's good. I'm going to do one more, show you one more thing. Okay, but I think that's pretty much it. The only thing that makes it harder is if you're just given harder things to integrate. You know, that's it really. That's the method. I'm just going to show you one more thing, which is like a kind of like a trick, but it sometimes comes in handy. So finally, I want you to try and integrate this, because it's worth knowing how to do. Okay, so I want you to integrate ln x dx. Okay, and you do it by parts. Okay, so I tell you what, we'll just do it now. Why is this one by parts? So why it doesn't look like you do it by parts? Why not? Yeah. So one of the values is going to be 1. Okay. Now which one? What do we want u to be? So I've got the u and the dv dx, and I'm going to have one of them just as 1, and one of them as ln x. So which one's which? Which one's which? Yeah. Okay. Can I do, if I make this one 1, can you tell me what v is? X, right. So this one must be the ln x. Can you tell me what the x is? 1 over x. What would have happened if I'd done it the other way around and I made the dv dx the ln x?
Well, no.
I'd have to integrate it, but what's the question? Yeah, so I'd just give myself the same question that I was trying to solve, right? Can you see that? Okay. So, let's see what we get. If I want to integrate ln x, it's going to be u times v, so x ln x, minus the integration of v du dx. Well, what's x times 1 over x? 1. So I get that. And what's the integration of 1? It's x.
So you got that place in the
Yes, so now it is in the formula book, yeah. Okay, but there you go. That's how you integrate ln x. Okay, sometimes, but the point of me doing this one is, it's nice to know what ln x integrates to and be able to do it. Okay, because it's just a common function. Second thing is, the two things that you're multiplying together, those two products, aren't always what you think. Okay, for example, let's say you had x squared ln x. Okay, something like that. Now you could split that up as x squared and ln x, but you could equally split it up as x and x ln x, or you could actually split it up as 1 and x squared ln x. So it's not always a split that's obvious. That's my point. Okay, but usually it's on your papers. But just be wary. Okay. All right, that's it. Integration by parts.